Hey guys, my name is Jason and today I'm going to show you how to factor. Today, we're going to be factoring quadratic expressions such as these three using a very popular technique called the AC method. What the AC method requires is for us to have our quadratic expressions written in general form. ax squared plus bx plus c. We're going to be looking at the first example, x squared plus 5x minus 6. We're going to first draw a big X used for organizational purposes. We're going to take our b from our quadratic expression, 5, place that value down here. Then we're going to take our a and c, 1 and negative 6, multiply those values to get negative 6, and place the product up here. Now we're going to think of two numbers that will multiply out to negative 6 and add up to 5. Negative 1 and positive 6 are those values. So now we're ready to work on our quadratic expression. We're going to change this 3-term expression into a 4-term expression. The 4th term will occur because we're going to break our 5x into negative x and positive 6x, because negative x and positive 6x will sum up to 5x. So if we wrote this, we wouldn't be changing the value of this original expression. With 4 terms, we can factor by grouping. So when we group these 2 terms and those 2 terms together, then look at this grouping and factor out an x. Look at that grouping and factor out a 6. We'll see that we get 2 giant new terms with an x minus 1 in common. If we factor that out, we're done. What happens in the AC method is we go from a 3-term quadratic expression into a 4-term unsimplified quadratic expression where we can factor by grouping and then factor once more to reach factored form. Let's look at a second example. In this second example, we need to be a little bit more careful because now our quadratic expression is not in general form. So we're going to rewrite this in general form so that we know exactly what our a, b, and c is. Using the AC method again, I'm going to draw out that x. We're going to take our b, 11, place that down here. Then we're going to take our a and c, 3 and 8, multiply those to get 24, place that up here. Now we're going to think of 2 factors of 24 that will add up to 11. So what are the factors of 24? 1 and 24, 2 and 12, and 3 and 8. 3 and 8 turns out to be the pair that will add up to 11 and are also factors of 24. So now, when we replace the 11x with positive 3x and positive 8x, group together these terms like so, factor out a 3x from here. Notice how I'm factoring the greatest common factor between the terms in each group. Here we have the factor 8. After that, we see that x plus 1 is in common, so when we take that out, we're done. So now, I have one more example to show you guys. It's going to be the hardest example, but we've already done 2, and so the AC method is pretty good with us now. So let's look at 10x squared minus 26x minus 36. these values are much bigger than our previous quadratic expressions, the numbers in our previous quadratic expression. So we should be a little bit smarter when we take on this problem. We can be smarter if we realize that these terms have a 2 in common between them. So if we factor out a 2 first, the AC method becomes a lot easier to work with. Because instead of multiplying 10 and 36, figuring out factors that will add up to negative 26, working with 5 and a negative 18 and negative 13 instead, with smaller values, we can get it done. Okay, so now our B is negative 13. Notice how I'm bringing the sign with me. 5 and negative 18, their product will be negative 90. And now, this value right here is negative. In the previous two examples, it was positive. So, if I listed out the factors of negative 90, I'm going to have a lot. But if I just listed out the factors of positive 90, so 1 and 90, 2 and 45, let's see, 3 and 30, going off the screen here, but alright, so we still got one more factor, one more set of factors, 5 and 18, and we got 10 and 9 also. Okay, I'll stop there. So, if we were listing out the factors of negative 90, we'd have a really, really long list. But if we just focus on the positive value and just look at these factors and realize that the 5 and 18 differ by a value of 13, and 13 turns out to be that number that we see here, it's most likely this pair, in which it is. So now we need to worry about whether our 5 and 18 are negative or positive, because their product has to be negative. So one of them has to be negative. Because the sum has to be negative 13, the 18 should be negative so that they will add up to 13. Negative 13, I mean. Okay. So now, the 2 comes back down, the 5x squared comes back, but the negative 13x gets replaced by negative 18x and positive 5x. Notice how if we just group these two terms together and those two terms together, we're not going to be able to factor out really much. So instead, we're going to rewrite this so that the 5x is going to be next to the 5x squared and the negative 18x is going to be next to negative 18. Because now when we group these two terms, and so when I group these two terms together, one thing I can do is make this plus, put a negative sign over there, and then group like so. From this first grouping, we can factor out a 5x, and so we have x plus 1 left. From this second group, we're going to factor out a negative 18, because I'm trying to get this term to be a positive x. So when I factor out a negative 18, we get an x plus 1 in common between these two new giant terms. So when we factor the x plus 1 out, we reach our final answer. 2 times x plus 1 times 5x minus 18. And that's it. Factoring can be challenging, especially with bigger numbers, but using the AC method, we're able to factor big quadratic expressions, such as these ones, in no time. Thanks for watching, guys.